Today, I will show you not only what working code looks like, but also a method that will help you get rid of chaos in your mind and learn to create solutions on your own. You won't just be able to follow along with the video, but you'll also learn to think in such a way that even when you turn off the screen, you'll be able to build the logic yourself and explain how it works. So stay tuned and watch the video until the end. Let's take a look at problem 1071, greatest common divisor of strings. Here, we can immediately move on to analyzing the problem statement. I've saved it here. Let's once again use the fishing method and try to carefully catch the keywords in order to fish out the important keywords that will help us better understand what is being asked of us. First, for two strings S and T. So here, it's clear that the first thing we have is this. Some string and another string. Here I can immediately understand that I'll be working with strings, and if I'm working with strings, then there is, in principle, a certain set of tools in code that are usually used. So from this keyword, I can already roughly understand in which direction we'll be moving next. Here, we're given the phrase D divides S. If only, if. And here we end up with this kind of formula. In general, I can say that on LeetCode there are some problems that are solved using some logic in code, and there are just logical problems. And this problem that we're looking at now, 1071, is basically more of a purely logical one. Another interesting point here is when I see a formula like this, S equals T plus T and so on. In general, whenever there's some formula where things are being added together, it often involves some kind of logical manipulation. That is, later on, when we continue to study and explore other problems in this subject, there will also be many different examples and situations where things are being added together, and because of that, as a result, we get some logical outcome or result. That's why, when it comes to these kinds of logic problems, I would say from my own experience that if you haven't encountered them before, it will be hard to understand and immediately learn how to solve them without practice. So, let me take a moment to clearly explain to you how to interpret this formula. Here, they provide us with a brief explanation, which means that T is concatenated. That's another important key word we can pick out and focus on. This means that the strings will be attached or joined together. So, as you can see, here the strings are being joined together to form a single, longer string. This is what concatenation is. With itself one or more times, that is, it can be once, or it can be an infinite number of times. That's it. So, based on at least the first paragraph, we understand that we have two strings, and somehow they will be joined together. In other words, here we are specifically talking about joining these strings together. Next, we have given two strings, string 1 and string 2, return the largest string x, such that x divides both string 1 and string 2. Here, especially for me, as someone whose native language is not English, it's a bit difficult to understand this particular wording, so when I was solving this problem, I immediately moved on to this section, and in general, it makes sense sometimes to ask for clarification. If you're in an interview, for example, you can ask, could you give an example to clarify? Because, for example, it's actually clearer than, say, this phrase here. From the example, you can see that if we have string 1 as ABC, ABC, and string 2 as ABC, then we get this result. And in this third example, if we have string 1 as lit and string 2 as code, then the result is an empty string. So, by analyzing this condition of our task, we can already get a general idea of which direction to move in. But let me show you once again in more detail what this actually means. Here, I've prepared a small example for you. So, for example, what they want from us is, we have string 2 and this is string 1. String 2 should fit into string 1, just like that, 1, 2, 3. This is a kind of general template, basically a general template that fits both into string 1 and into string 2. And it doesn't get disrupted when repeated. So, as you can see, if I substitute it here, we get a complete match. There's no difference at all. That's why this template, apple, orange, banana, works for us here. And so the result here will be apple, orange, banana. Here, it's clear that apple, orange, banana can be any symbols like ABC or something else, and so on. Just to make it visually clear, I made it in the form of pictures. So, for example, here's our second example. You see, again, we have apple, orange, banana. Here, it fits. But in the second case, we have a lemon here. You see, it doesn't match. And that's why here this rule breaks, so it doesn't fit the entire string anymore. So here, it doesn't fit anymore. And here, in the third example, we get the following situation. The first three symbols match, but the next ones don't. You see, there's a banana here. Here as well, it turns out that in fact we actually do not meet the requirements of the task, so only the first one, in this case, meets the requirements. The second and third do not meet the requirements of the task. If we take a look here, I drew several examples, so we've gone over the task requirements. Now let's take a look at the actual code itself. I've already written the code, so let me explain what we have here. We have some manipulations going on, but the first thing we need to do is build a formula like this. If we add string 1 and string 2 together, and on the other side, string 2 plus string 1, they should correspond exactly. This is simply a logical solution because, look, for example, if we have ABC, ABC, and string 2 is also ABC, then no matter how we concatenate these strings, they should always match each other exactly, each time. So if they match, that means we have a common pattern. If they don't match, that means something is off somewhere. Here's another example. You see, here we have 6A and here we have 3A. And no matter how you look at it, that is, whether we concatenate the first string with the second or the second string with the first, the result of joining these two strings is still the same. So we can move on. That's why, as I already mentioned, this is simply a logical manipulation, a logical solution. There are no databases here, there are no data structures. We're not using any hash maps, lists, or anything like that here. It's just a logical deduction from what we need to do. That's why when solving a problem on LeetCode, you need to be able not only to write code, but also to think logically. For example, here's the second example. Let's take a look further. Here we have the first line as lead, the second line as code. And here, if we add the first line to the second, we get LeetCode. If we add the second line to the first, we get code lid. So here we have a match. No, actually, here we have a mismatch instead. And that's why in this case we can't have a solution to our problem. It's the same here. You see, if we have a bab and the second line is abae and we concatenate them for the first time, first line plus second line, we get this kind of string. If we concatenate line 2 plus line 1, we get this kind of string. And they are different. And this is a typical, simple, easy solution that doesn't require any complications in the code. But after we've completed this first stage of validation, now we need to understand so that it's clear that our strings are indeed valid. That is, we can now try to identify or find some common pattern, a common tile for our two strings. And this can be done using the following tool. In Python, there is a tool called GCD. Here, I want to say once again that when you are studying and practicing problems on LeetCode, as I mentioned in the previous lesson, you simply need to focus on increasing the number of tools and techniques you bring with you to the interview. And this is one of those particularly important tools that will be useful to you in solving problems in the future. So the tool for finding the basic greatest common divisor or GCD pattern is a helpful method that enables us to identify this fundamental pattern for both of the given strings. We will continue to use this pattern as we move forward. So once again, when you're studying and working through problems on LeetCode, don't just solve the problems for the sake of completion, but instead treat all these different solutions as a valuable way to expand and enhance your personal toolkit of problem-solving strategies. That is, you're not just solving problems, but you're actively learning new tools, techniques, and approaches. And the more problems you solve, like we're doing together right now, the more tools, strategies, and methods you'll have at your disposal for solving future problems. And the more tools you'll be able to take with you and utilize during interviews when you go through the interview process. Now, what does this look like in Python? There's a formula, a special built-in method, where we can send or pass two long values, two strings, two numbers, two digits, or two integers, and it will give us the result. This method is very useful and can be applied in a variety of situations, making it a powerful addition to your programming toolkit. Let's do a more detailed and thorough analysis of what is actually happening there. Here, I've manually written out in detail exactly what is happening inside this formula, because if you're coding in another programming language, you might not have access to this particular solution, and you'll have to write it all yourself, step by step. Let me explain in a bit more detail, manually, what exactly is happening inside this formula, inside this function. Again, there is some logical computation going on here. Let's take a look at how this appears in terms of code. It's not all immediately clear, so first, I'll just explain it using some numbers, and then it'll become much clearer to you. So look, as input, we receive numbers. In our case, that's the length of string 1 as well as the length of string 2. For example, the length of the first string is 6 and the length of the second string is 4. And we need to find the length of the base pattern that fits into both strings. How is the remainder calculated? So in the number 6, the number 4 fits in just once. In 6, 4 fits in only one time. And 2 is the remainder. So the remainder in the first case will be 2. When we look at 4 and 2, there is no remainder because 2 fits into 4 exactly 2 times. That's why the last value before 0 is our result. This is simply a mathematical calculation. Here we've already stopped and we return this 2. For example, let's look at a second example. Here we have a string of length 18 and a second string with a length of 12 characters. So again, we're looking for the remainder in 18. 12 fits in only once and the remainder from this will be 6. See, that's 6. Next, we observe that 6 fits into 12 exactly 2 times and there's no remainder. So here in this calculation, we get 0. And here we return the result, which is 6. Sometimes it also happens, for example, that we have even and odd numbers. If our first string has a length of 15 characters and the second string has a length of 9 characters, let's again look at the mathematical manipulation. So 9 fits into 15 only once and the remainder will be 6. Then we put 9 here. There you go. And how many times does 6 fit into 9? Also once. And the remainder is 3. So we put the 6 back in the first place. And we see how many times 3 fits into 6. Exactly 2 times. And the remainder is 0. So the result that was before the 0, the 3, is exactly the result we need. But what happens if we switch them around? So here, you see row 1 is greater than row 2. Here, row 1 is greater than row 2. But what if row 2 is greater than row 1? In that case, they are swapped first. There you go. See, we swap them. The 8 moves to the second position in the equation and 12 takes the first position in the equation. And then, once again, we check, using exactly the same logical process as before, how many times the number 8 can fit into the number 12. The answer is once, with a remainder of 4. So the 8 goes here to the first position and the 4 is placed in the second position. And here, once again, we see that 4 fits into 8 exactly 2 times. And we encounter 0 again. And this 4 is our result. It is the product of a logical manipulation, a careful process that helps us determine how many times something occurs. By applying logical reasoning step by step, we can clearly see how this answer is reached, making the solution understandable and reliable. This combination occurs here and here. There's no code here, nothing supernatural, there are no data structures here. In the end, this is what we need. And when we pass 2 strings, specifically the lengths of the 2 strings, you see the lengths of the 2 strings, into this kind of formula, right here, we understand that the common pattern for these 2 strings will be, for example, of length 3. So if we pass our string ABC, ABC, and ABC here, that is the length of the common pattern. Using this manipulation, we'll know that the length is 3. See, the length is 3. And basically that's clear. And that's correct because here we have 3 characters and here we have 3 characters. If we look at it visually, yes indeed, ABC is the common pattern that fits both here and here. There you go. But here again, I want to draw your attention to the fact that in solving this problem, we made a small manipulation. We actually moved away from comparing strings and switched to pure mathematics. See? Honestly, for me, when I was studying LeetCode and learning these algorithms, it was something new and probably confusing that we just moved from code to mathematics. And here, you just need to develop this small skill. In this case, there really isn't any kind of super complicated mathematical activity involved. Usually it's just plus or minus, or maybe a remainder. Let's see what we've come to. At the first stage, we checked whether our strings were valid or invalid. We did this using some kind of logical manipulation, logical operations. And then, once we realized that our strings were valid and we could work with them further, we found the length of the common pattern, specifically the length of the common pattern and the common pattern itself, which we need to return. You see, we need to return the longest string itself. We haven't found the common pattern yet. We only know that the length of this pattern will be essentially a certain number, and then at the final stage, right here, when we already have some number here, we will use this kind of Python construction, such as a colon and 3, for example, or fobabamo, to take from our first string only the number of characters that we calculated as the length of the common pattern. So if here, for example, we have 6 as the result, then from our first string we will take the first 6 characters, meaning we will extract exactly those 6 characters from the beginning of that string. Here, if our result is 2, then we will take 2 characters from our first string. If our result is 3, then we will take 3 characters from our string. If our result is 4, we will take 4 characters from our string. And in this way, when we select the number of characters, in this case, we will take 3 characters. This is the common pattern that fits the first string and the second string. Here we will take 2 characters that fit for us. See, 2 characters, they fit both here and here. Here it repeats twice and here it repeats 3 times. But here we don't have a common pattern because we didn't pass the first validation. And that's why basically in the third example it will just fail completely. This is what the formula looks like. Let me show it again. Which allows us to calculate how many characters we need to take from our string. Here of course I added a bit more code. Actually you could write almost all of this in a single line. This is called the remainder. And here we first calculate the remainder using this remainder sign. And then we swap them. You see, this is a purely Python specific construct. So by swapping them, we perform this kind of manipulation. First, we have the first length here, 18, the second length, 12, and then we get the second length and the remainder. The remainder is simply what's left over. That's why you see first length, second length, and the remainder. Then, when this while loop continues to the second iteration, instead of the length of the second string, we get this remainder from our first calculation. The same thing happens here as well. And so, basically, it doesn't matter, even if it's a very long string. This remainder will always end up here in the second position. And then, sooner or later, no matter what numbers you have next, you'll eventually encounter a 0 here. That's why, as you can see here, as long as the length of the second word is not 0, this loop will keep running. And in this way, step by step, we keep on gradually reducing our value by repeatedly using the remainder operation, which is also known as the modulo operation. This process continues, and in the end, after several iterations, we will eventually find exactly that specific remainder and that common pattern length that perfectly fits both the first string and the second string. So, as a result of this process, our solution turns out to be very short and elegant. So first, before anything else, we perform this kind of manipulation, which is essentially just a check, a validation step, to ensure everything is correct before proceeding further. And then we use this kind of approach. Here I also want to point out that this is called the Euclidean algorithm. As you can see, I've written it down in my notes again as keywords. I've also written all of this out here. I've made a definition of how it all works. This is just for myself, so that at any moment I can open it and read it. For example, when I'm preparing for another interview, and I'll need to remember and look everything up 100 times again. I'll just open up this file of mine from the first lesson, and now this lesson too. And I'll keep reviewing all of this over and over again. So if you want to get my file, which will be constantly updated, follow the links in the description of this video. There, I'll be posting more materials that I personally use. So, as you can see here, we're doing the first manipulation again, the second manipulation, and the third manipulation. And in this way, all our tests pass. And everything works for us. As you can see, test 1 passed, test 2 passed, and test 3 passed. Now let me show you how this looks in the logs, so you can see even more clearly how it works. Here's my solution, which I also wrote down for myself so I could refer back to it later and make sure I understood every single part of the process, but in a very, very detailed form. Just look at how many logs I added throughout the entire process. Why did I do this? Well, let me explain again, and I'll repeat it for emphasis. It's simply much more convenient and effective to study the solution itself and track how everything works step by step. Here are the logs I ended up with after carefully documenting each stage. For example, let's say I have the string ibesi and another string also ibesi and yet another string again ibesi. Then I check, so if I take string 1 and add string 2, the result is ibesi, and if I take string 2 and add string 1, that also equals ibesi. Here, I make sure to write all of this information into the logs so I can see exactly what is happening at each step. As you can see, I described everything in the logs in great detail, making sure to include every relevant piece of information so it would be easier and clearer for me to understand what is going on. Then, using this formula, which I refer to as CD of length, I see that length 1 is 6 and length 2 is 3, so I have 6 and 3, 6 and 3, and the remainder is 0. And so my result is 3. And then, as the final step, I take the first 3 characters from this first string of mine, which gives me the answer I was looking for. By documenting each of these steps in such detail, I can always go back and review my thought process, making it much easier to understand and learn from my own solution in the future. The first 3 characters from my first string are ABC. And I can see all of this in the logs. See candidate base and verification ABC. The number of times ABC appears in the first string is 2. The number of times ABC appears in the second string is 1. And I also added some kind of validation here as well. Again, I wrote quite a lot here, and everything is carefully logged for future reference. Another advantage of this approach, where I write out the logic in great detail, is that I go over in my mind once again what is happening at each step. This helps me to reflect on the process and understand the reasoning behind each part. That's why I start to understand in detail what the algorithm is and how it works, step by step. So I recommend using this and turning to this method of studying algorithms as well, because it helps you internalize the concepts and truly grasp how everything fits together. I recommend this again because when you just write a solution like this, your brain can basically forget all of that logic. But when you write out every single line in detail, when you carefully and thoroughly write out each and every solution, and when you make sure to document every logical step, then quite naturally, everything will settle and become clear in your mind. Later on, this GCD method, which you have practiced and understood so well, will automatically come to mind even after a long time has passed. And this is especially true for those who don't code in Python. For example, I myself code in Kotlin, and even if, say, I'm asked to implement a solution not in Python but in Kotlin, I can still do it, even if I don't know whether Kotlin has such a built-in formula or not, one that can perform this operation for me. That's why I still recommend everyone to work through the logic in detail. And this not only helps you debug the code you write, but it also keeps all the details in your mind, which you can later use for other tasks or in interviews, because sometimes you might solve 10 problems and then nothing stays in your head afterwards. That's why you should write logs. It also helps you retain as much information as possible in your mind for future work. Be sure to subscribe to my page and check the links in my profile. There you'll find a huge amount of additional materials and full reviews that will save you time when learning algorithms.